So welcome to Electronic Signal. You are watching Signal System lecture series, and today the topic of discussion is the representation of discrete time signals. Okay, so we have discussed about the discrete time signals. Discrete time signal is a signal that are defined only at integer values of the n. Okay, and these are represented by the symbol. There is the signal x of n. Okay. So let us see how the digital discrete time signals can be represented. Okay, so there are various way of representation of discrete time signals. So let us see that. So a discrete time signal that is x of n is a function of independent variables. That is an integer. So x of n is defined as the integer values of n. Okay. It is the discrete time signal is not defined the instant between the two successive samples. Okay? So instead of define the real values of time, so what we are defining at integer points of n. Okay, so no value is defined at n equal to 1.5 or something like that. Okay, so there is the meaning. So it is not defined for instant between the two successive samples. Okay, so we are defining at the n values of integer value, that is 0, 1, 2, 3, likewise. Okay, minus 1 also. So likewise we can define the values of n. Okay, so x of n is not defined at the non-integer values of n. Okay, so non-integer values of n means it is not defining between the at n equal to suppose 0.5 or n equal to 1.6, likewise. Okay, so it is defined for only the integer values of small n. Okay, so x of n is obtained from the sampling of an analog signal, that is the x of n. So x of n is analog signal. So if we sample the analog signal at some regular interval of time, that we will obtain the x of n. Okay. So this is nothing but a sampling theorem. Okay. So in this sampling theorem, what so x of n is the discrete time signal. So what we are doing is that by taking the samples of the analog signal x at every t second. Okay, so that is the meaning of the sampling. Okay, so that can be t is the sampling period. What t is the sampling period? So that is the time between the two successive samples. Okay, so suppose there is a means suppose we have a this is the x, this there is a sampler. Okay, so this is a sampler. So we have a analog signal, that is x a of t. Okay, so x of t is the analog signal. Okay, x of t is the analog signal. So what will the output of analog signal? The output of a output of a sampler. The output of a sampler will be a discrete time signal. Okay, it is a discrete time signal. Okay, discrete time signal. So it is the output of the sampler is x of n, which is the discrete time signal, which is equal to x a of n of t. Okay, so this is the uh, process of sampling. So we are taking the samples of the analog signal to get the discrete time signal. So suppose this is the analog signal. So this is our analog signal. Okay, so this is suppose analog signal of time t. So what we are doing? So at regular interval of time. Okay, so suppose n equal to 0, 1, 2, likewise. Okay, so this is our analog signal. So you can see, so this is the same analog signal. So what we are doing, suppose n equal to minus 1. So taking this minus n value. Suppose n equal to 0. So this is the n equal to 0. Suppose n equal to 1, 0, 1. Then n equal to suppose 2. Okay, so 2. Then n equal to 3. Likewise. Okay. So we are taking the integer value of n. Okay, n equal to 5. Okay, likewise. Okay, so this is a, so we are taking the sample values of x a of t. Okay, at regular interval of time. So this can be t. Okay, then this 2t, then 3t. Okay, so this is the n value. N value equal to 0 means it is the 0. Then we have n value equal to 1. So this will be t, then 2t, then 3t, likewise. Okay. So we are taking the values of the samples at regular interval of time. Okay. Therefore, we are obtaining this discrete time signal. So discrete time signal are obtained by continuously sampling the analog signal at regular interval of time. Okay, so that is the meaning of the sampling. Okay, so now so there are various form of representation of this means discrete time signal. So one of the representation is the graphical representation of a discrete time signal. So we can see, so these are the values of n. Okay, these are the value of n. So n can be -4, -3, -2. These are all integer values of n. Okay, then we have it at 0 the x of n equal to 2. At 1 the value is your means this value is your x of 0. I can write x of 0 equal to 2. Similarly, x of -1 we have the value is equal to 1.5. Okay, so likewise, so x of -2, what is the value? X of -2, the value is your 0.5. So x of n is your 0.5 at n equal to -2. Similarly, x of 5, how much? The x of 5 equal to 1, 1.0. Okay, so these are the this form of representation is the graphical representation of this discrete time signal. Okay, so this is the graphical representation of a discrete time signal. So likewise, functional representation. Okay, so this is the functional representation of a discrete time signal. So for n equal to 1 and 3, the x of n value is equal to 1. Okay, similarly n equal to 2, the value is 4, and 0 else likewise. Okay, so this is the called the means functional representation. So for x equal to x of 1, the value is 1. Okay, these are the n values. Okay, for x of 2, what is the value? The x of 2 equal to 4. So likewise, x of 3, the x of 3 value is 1. Okay, and else it is the all the values are 0. Okay, so this is the functional representation of the discrete time signals. Okay. Next we have tabular representation of the discrete time signal. So tabular representation you can see. So these are the values of n. The corresponding values of x of n are formed in the form of the table. Okay. So x of -2, the value is 1. Okay. So x of -1, the value is 0. Likewise, x of 3, the value is, what is x of 3? Equal to 0. So likewise, so this is called the tabular representation of the discrete time signal. Okay. So next is the sequence representation. Okay, so this is the widely form of representation, the sequence representation. So this is the for one infinite duration signal. It is represented by this n equal to 0. So n equal to 0 is the time origin. Okay, that is indicated by the symbol of arrow. Okay, so let us take an example. So this is our x of n. So there is a arrow mark. This arrow indicates that that is a origin. Means this arrow indicates that n equal to, there is a reference, that is the arrow mark. So this equal to n equal to 0. So at x of 0, the value is equal to 0. Okay. Similarly, at x of -1, these are the -1, n value is -1. This is n value is 0. This n value is 1, 2, 3, 4, 5. Likewise, these are the values of n. Okay. So x of -1, the value is 0. X of 1, that is 1. X of 2, that is 4. X of 3, the value is your 3. X of 4, the value is your 2. X of 5, the value is equal to 0. Okay. So this is called this is the infinite duration signal. Okay. So here the n value is your in infinity. So that is why. So but there is a arrow mark. The arrow mark indicates that it is a time origin at n equal to 0. Okay. So this is our sequence representation of it, and this is the infinite duration signals. Okay. Similarly, a finite duration signals can be, and this you can see, a finite duration signal can be expressed represented as this in this form. So this is the x of n equal to 3 minus 1 minus 2 5 0 likewise. Okay. So how many samples are there? 1, 2, 3, 4, 5, 6, 7. Okay. So that is why this is the 7 points sequence is there. Okay. So this signal consists of the 7 samples. So that is called as the 7-point sequence. Okay. So this arrow mark, what is this arrow mark? The arrow mark indicates that that is the origin. Okay. So this is the n equal to 0. Okay. So we have the signal at x of 0 is -2. Similarly, x of that is -1, it is -1. So these are the x of -2, the value is 3. Okay. So this is n value minus, sorry, this n value is your the -1, this is -2. Okay. So this is the n value is 1, 2, 3, and 4. Okay. This is the n value 0. Okay. So this is the values of n. So if there is a arrow mark, that is the signal the signal value is at n equal to 0. Okay. So if there is no arrow mark, suppose x of n equal to 1, 2, 3, 4. Okay. So x of n equal to 1, 2, 3, 4. This is a finite difference given. If there is no arrow mark is given, so actually this origin is your first point. Okay. That is the origin. Okay. So if there is no arrow mark, you start at n equal to 0. Okay. The signal is starting at n equal to 0. Okay. So this is the representation of the discrete time signal. So we have there are 4 type of representation are there. Okay. So out of which the sequence representation of discrete time signal is widely used. Okay. So these are the representation of discrete time signal. So stay connected to this channel. Thank you for watching this video. Okay. And if you have any doubt, please free to ask in the comment section. Okay. Thank you all. Have a nice day.